Ever since the statistical methods like EOF has been invented, and people have been trying to look at these modes. And over time, we all know that there are so many modes these days. They probably consist of all these three only. Something like an AO or NAO is more internal. And then others refer to something more like a BNA that has tropical forcing. When it comes to forcing, it's always tropical. And then there are the intertwined modes. It's very complicated. We have to know all these modes in order to understand their origins. In the rotating sphere, the size of the Earth to rotate just like the Earth's rotation. And over time, all those fluids start to reach equilibrium. And then you start to form jet. This is the U. They maintains the energy through the mean state and eddy energy exchange. And then over time, they will change. By comparing just one snapshot that I have kind of run it through the later time step, you can see that compared to the initial equilibrium state, that the jet position and intensity is different. So that means there's an internal variability. It's simply stochastic forcing. So now we started to expand the zonal mean into the horizontal structure of stationary waves by simply imposing a cylinder terrain at 30° north to where the Tibetan plateau is located and what would be the wave. And it turns out that this wave, this ridge location is at where Western North America is, right? If you put a terrain like this, you're going to generate something like that. And then, so the Tibetan plateau is the first and foremost reason that you have the ridge trough structure that we see in wintertime circulation. So if you put this variability, they simply try to pick up the major mode of the jet stream or zonal circulation, just two internal jet profile. And you put these two profiles into the general circulation with just the mountain forcing, and then do the difference. So this is the stationary wave difference that comes from the two jet profile. Then you start to see the amplified high-low patterns here, right? Now let's talk about external forcing. External forcing comes mainly from the tropics. The amount of energy is dominant by the warm pool, okay? And this is where if you perturb here in the equator, and this is the stationary wave which you will be seeing, that you eventually get the balanced stream function in response to the forcing source, eventually. And if you put back the zonal mean, this is what the wave looks like. Only tropical forcing can induce the wave energy propagation that reaches polar regions. I still did a little bit of myself just to solve the barotropic equation, and then you can also get a wave forcing like this. We now have these two, internal and external forcing, right? Every time you see an anomaly, there's always a component of these two.
How can a stationary wave flip if its external forcing is fairly constant?
When we talk about the flip or the dipole, it is not a flip of the stationary wave. It simply means the stationary wave becomes weaker. So the so-called flip really is in anomalous sense, right? So the forcing will also be anomalous, or if the ridge becomes weaker, the forcing area might have an anomalously weak forcing. That's what I mean. All right, coming back to this ridge, you can see this is the 2014 ridge. What it does is it's not like it creates a stationary wave. It simply amplifies the stationary wave because the blue line is the climatological waves, right? And if you could go relatively flat, and that's what I mean by flip. Is this dipole mode a new mode? Well, it is not. I keep amplifying that it's not. It's something that people know long time ago. And so I put all this paper and project it in the same way simply because if you are familiar with this literature, you can pretty much know that all these papers at the time try to understand what kind of forcing produce a wave pattern that resemble observation. So these are all the forcing response. And if you dig into the paper, you're going to find out that they put tropical forcings about right here. And that's resembling the 2014 ridge. But again, we want to know why. Okay, this is the theoretical argument. And if you put forcing here, so you would generate the wave dispersion southward and northward. When you place a tropical forcing, only the long wave can penetrate Arctic Circle. Wave number 4 barely touches Arctic Circle. Now you combine these two, you can start to see the differences. The forcing they put is not equator. The forcing they put is actually subtropical, or maybe 15 degrees. It's certainly, then this is the polar region, the Arctic Circle. So you can see only wave number 1, 2, 3 remains, right, in this region here. There's been an NCAP paper that came out arguing that's internal variability, and they're not wrong. This is from their paper. So you see the wave trend and see how many waves. Wave number 5, it has no particular forcing, but you can see that the energy is circumglobal, which means it's trapped in jet stream. It doesn't go north, it doesn't go south, right? It could have tropical forcing, but then it's still trapped in the jet stream. Now, if you look at within the Arctic Circle here, there's no wave energy. What they are saying is you have this ridge and trough. My argument is that if you look at 2014, you're going to see that, yes, there is a wave number 5 signal. They have a resemblance, but they only explain, partial variance. But if you look at the polar regions, this is when their argument can't explain. Now you're seeing this combination of wave number 1 and 2, maybe a little bit 3 here. If you remember, then only longer waves can penetrate, and longer waves are only possible from tropical source. So their wave number 5 pattern comes into the jet stream waveguide concept is roughly here. Wave number 5 doesn't enter the polar region. The closest mode I could find is the 1987 paper by Tony Barskin. He named this the tropical North Hemispheric pattern. That's the only thing that has this dipole across North America. This is mode 9, it's just very weak. So the working hypothesis about this is all 4 combined. So we have internal variability. Now we have explained that. And then we have the jet trapped short waves, right? We have the tropical external force circulation. And we also have the Arctic inference. The Arctic inference and the internal variability is supposed to be one thing, if not for global warming, because AO is internal, but then because of the Arctic amplification, this mode might be changing in one way more than the other.